Hi, welcome back. Let's talk about divisibility. Let's say we have two integers, a and b, where a is not equal to 0. We have 5 different ways to say the same thing. We could say a is a factor of b, a is a divisor of b, a divides b, b is divisible by a, or a divides into b evenly. The mathematical way to say those things is that there's an integer k, such that b is equal to a times k. And this is something that we talked about in one of our first videos when we were introducing this notation. A vertical bar b means that a divides b, or any other of these equivalent formulations. As some examples, 2 divides 22, because we know 22 is 2 times 11. Similarly, 3 divides 90, because we know that 90 is equal to 3 times 30. At the same time, we would write 4 does not divide 50, because there's no integer where 50 is equal to 4 times that integer. If we think back to our division algorithm, we know that 50 is equal to 4 times 12 plus 2, and because there's this remainder of plus 2, then 4 does not divide 50. And so what we're saying is that a divides b when a is greater than 0 is the same thing as b mod a is equal to 0. A more general example that we have is that 1 divides n for all integers n, because we can write n is equal to 1 times an integer, where n itself is that integer. Let's talk about some rules surrounding divisibility. Here we're going to let a, b, and c be integers. Here's our first rule. If a divides b and b divides c, then a divides c. Let's explain why. If a divides b, there is some k1 such that b is equal to k1 times a. If b divides c, there is some k2 such that c is equal to k2 times b. Putting those two together, we can write c is equal to k2 times b, which is k2 times k1 times a. Combining those constants, we get c is equal to k2 times k1 times a. We'll write k2 times k1 as capital K. And so this equation tells us that there is some integer capital K such that c is equal to capital K times a. That's the definition of a divides c. Here's another rule. If a divides b, then c times a divides c times b. Again, we start from the definition. If a divides b, then there is some k such that b is equal to k times a. If we multiply that equation on both sides by c, we get c times b is equal to c times k times a, which is the same as k times c times a. So that means there is some integer k such that c times b is equal to k times c times a, which is the definition of ca divides cb. Let me give one more rule that will be useful in a little bit. And that is, if d is a divisor of a and d is a divisor of b, then for all integers x and y, d is also a divisor of ax plus by. So not only is d a divisor of a and d a divisor of b, but it's a divisor of every combination of a and b as well. So in the situation where we're using this rule, we'll be using this form, where if d divides a and d divides b, then d also divides a minus q times b for an integer q. You can see we're using x is equal to 1 and y is equal to negative q to give this expression, a minus q times b. Alright, so put that in your pocket. We'll come back to that later, and I will see you in the next video.